Today we begin our study over solving linear systems. So you're going to need a piece of graph paper, and I want you to draw a 10 by 10 grid. You need at least 3 different color writing utensils and a ruler. Systems of equations, and this basically is going to cover some of the vocabulary that we're going to talk about when we're dealing with systems. We're going to start with the definition. What is a system of equation? It's a set of 2 or more equations that contain the same variable. The solutions. Now, when we talk about solutions, you think of answers. Well, what's the solution to a system? It's a point or points that make the equation of the system true. There are 3 types of solutions for a system that we're going to be talking about. Okay, what I need you to do is on that 10 by 10 grid, you're going to be graphing some lines, and we're going to be talking about the vocabulary. The big question is, how do we solve a system of equation? Well, it's easy. We're going to be finding the point where 2 or more equations intersect. So I want you to take your writing utensils, and I want you to graph these 2 lines. X plus y equals 6 and y equals 2x. Okay, as you can see, both lines are graphed. The red line is y equals 2x, and the white line is x plus y equals 6. And you notice that they intersect. That intersection is the solution to my system. We call that the point of intersection. We have other types of solutions to systems. We can have an infinite number of solutions, and that's going to occur when the equation has the same slope and the same y-intercept. Those are also known as dependent systems and also consistent systems. A dependent system is when your equations have the same slope and the same y-intercept. A consistent system is an equation that has at least one solution in common. Okay, this is an example of a dependent consistent system. If you graph those 2 lines, you're only going to see one line. Okay, we graphed this one in the previous slide, and we noticed that they had a point of intersection. Well, this one only has one solution. When your 2 lines intersect, there's one solution. This one is known as a consistent and an independent system. Consistent, they have at least one point in common. Independent, they have different slopes. And then last but not least, we can have a system that has no solutions. When your lines are parallel, they never intersect, therefore they have no solutions. This one's known as an inconsistent system. If a consistent system has at least one point in common, an inconsistent system has 0 points in common. Okay, this is kind of a wrap-up of the 3 types of systems. As far as solutions, we can have exactly one solution. So they have one point of intersection. That means it's a consistent, independent. The graphs are intersecting lines with different slopes. We can have an infinite many solutions, which means it's consistent, dependent. The graphs are coinciding lines. They have the same slope and the same y-intercept. Or our system can have no solutions, which means they're inconsistent. The lines are parallel. They have the same slope but different y-intercepts. Now we're going to look at different methods for solving systems. Graphing, of course, we just looked at that one. We're also going to examine what to look for with tables. We're going to use an algebraic method, which is substitution, and another algebraic method which has 2 names. Some teachers call it elimination, and some people call it linear combination. Alright, when we get to class, we're going to be solving systems by graphing. See you in class.